Define function. In mathematics, a function is a rule that assigns a unique output value to every input value in a given domain. More formally, a function is a relation between a set of inputs, called the domain, and a set of possible outputs, called the range, such that for every input in the domain, there is exactly one output in the range. Functions can be represented in various ways, such as equations, graphs, or tables. The input values are usually denoted by the variable x, and the output values are denoted by the variable y or f, x. For example, the function f, x, equals 2x plus 1 is a rule that assigns an output value to every input value x in the domain of real numbers. For any value of x, the function will output a value that is twice x plus 1. Functions are a fundamental concept in mathematics and are used to describe a wide range of phenomena, from simple arithmetic operations to complex physical, biological, and social processes. History of function. The concept of a function has a long history that dates back to ancient Greek mathematics. However, the modern concept of a function, as a rule that assigns a unique output value to every input value, was developed in the 17th and 18th centuries by mathematicians such as Descartes, Fermat, and Leibniz. One of the earliest examples of a function was the concept of proportionality, which was used by Euclid and Archimedes to describe the relationship between two quantities. This idea was later extended by the Greeks to include other types of functional relationships, such as those involving curves and surfaces. In the 17th century, René Descartes introduced the coordinate system and the concept of an equation, which paved the way for the modern understanding of functions. In his work, Geometry, he showed how curves and surfaces could be described by algebraic equations, which gave rise to the idea of a function as a mathematical object that could be represented by an equation. In the 18th century, mathematicians such as Leonhard Euler, Joseph Louis Lagrange, and Pierre-Simon Laplace developed the theory of functions further, introducing the concepts of continuity, derivatives, and integrals. These ideas laid the foundation for the development of calculus, which is now a fundamental tool in many areas of mathematics and science. Since then, the theory of functions has continued to evolve and has become one of the most important and widely used areas of mathematics. Today, functions are used in a wide range of fields, from physics and engineering to economics and computer science, and continue to be a key area of research and development in mathematics. Uses of function. Functions are used in various fields of mathematics and beyond for a wide range of applications. Some of the common uses of functions include modeling real-world phenomena. Functions are used to model and describe various physical, biological, and social phenomena. For example, in physics, functions are used to describe the motion of objects, the behavior of electromagnetic fields, and the propagation of waves. In economics, functions are used to describe the relationships between variables such as supply and demand, production and cost, and consumption and income. Solving equations. Functions are used to solve equations in various mathematical disciplines, including algebra, calculus, and differential equations. By finding the roots or solutions of a function, one can solve complex problems involving variables and equations. Analyzing data. Functions are used to analyze and interpret data in various fields such as statistics, machine learning, and data science. By modeling data with functions, one can make predictions, identify trends, and extract insights from the data. Optimization. Functions are used to optimize various parameters in engineering, finance, and other fields. For example, in optimization problems, one tries to find the optimal solution to a problem by minimizing or maximizing a function subject to certain constraints. Computer programming. Functions are a central concept in computer programming and software engineering. Functions are used to organize code, break down complex problems into smaller, manageable components, and make code more modular and reusable. In summary, functions are a fundamental concept in mathematics and are used extensively in various fields for modeling, solving problems, analyzing data, optimization, and computer programming. Example: the Cartesian product A times A has 9 elements, among which are found -1, 0, and 0, 1. Find the set A and the remaining elements of A times A. Since A times A has 9 elements and -1, 0, and 0, 1 are both elements of A times A, we know that there are 7 remaining elements in A times A. Each element of A times A is of the form A, B, where A and B are elements of A. Since there are 9 elements in A times A, we know that there are 9 possible pairs, A, B, that can be formed using elements of A. One way to solve the problem is to use a table or a diagram to list all possible pairs of elements in A and see which ones are missing from A times A. We can start with the given pairs -1, 0, and 0, 1. We can see that these pairs differ in the first and second components, respectively, and that both components are either -1, 0, or 1. Therefore, we can guess that A is a set of integers between -1 and 1 inclusive. To find the remaining elements of A times A, we can list all possible pairs of integers between -1 and 1 inclusive, and check which ones are missing from the given pairs. -1, -1, -1, 1, 0, -1, 1, -1, 1, 0, and 1, 1. We can see that the pairs -1, -1, -1, 1, and 1, -1 are missing from A times A. Therefore, the set A is A equals -1, 0, 1. And the remaining elements of A times A are -1, -1, -1, 1, 0, -1, 1, -1, 1, 0, and 1, 1.